Hi guys, in this video I'm going to show you the experiment 14.4. Okay, 14.4. Now this experiment consists of a lot of reactions and I'm going to show you one by one in a more organized, systematic manner. Now basically we try to study the reaction between different metal ions with different base. And to be more specific, we want to look at the reaction of sodium hydroxide and ammonia against different metal ions. So right now, as you can see down here, I have shown you 9 samples which contains different metal ions. Now all of these solutions are prepared according to your lab menu. So if you go to your lab menu on this page, you see they have shown you altogether 9 different samples with different metal ions. So I try to align them the same way as your textbook, starting from here, calcium ion, and then magnesium ion, so on and so forth. Okay? So I will do it one by one so that you guys can see it properly. Okay? So let's start with adding the solution into the test tubes. So according to the menu, we want to add 2 cm cube of each of the sample to the test tubes. But you know, it does not necessarily require 2 cm cube. So I will just add 1 pump measure of each to the test tubes. So you see, you need to be very organized when you are performing reactions like this, because you see we have so many different samples and each you need to use a different dropper to transfer them. Otherwise, the sample get contaminated very easily. For most of the sample, they are colorless. Some of the sample has a colored. So that's why you need to make sure you are doing the right thing. Otherwise, you don't know which one is which. So you can see my practice here. I try to actually align the droppers, the test tube, and the reagent bottle in an orderly manner. And you can actually follow my practice if you have a chance to do something similar. And I believe like this way of working can also be used in different subjects or even in different things, different tasks in daily life.
So now I have added 6 samples. This is the 7th, which is lead 2 ions. And now is the copper 2 plus, the most recognizable one with this beautiful pale blue color. And last but not least, we have the silver nitrate containing silver ions.
So you see my test tube rack is full, so that's why I have prepared another test tube over here, okay, where I will add, for silver nitrate, we don't add 1 pump. This is quite expensive. I just add maybe small amount, okay? And to that, we are going to add the sodium hydroxide. Now here, adding sodium hydroxide, we don't add 1 pump each. According to the menu, we will actually add a few drops onto each sample, and then we will add excess. So here we are looking at 2 different observations. One is when we add a few drops of sodium hydroxide, what do we expect to see? And secondly, when we add excess sodium hydroxide, what will we expect to see? Some of the sample may have a different observation, some of them just stay the same. So let's start with calcium, okay? So sodium hydroxide is here, I'll just put it at the back. Now we can move the camera a little bit closer so you can get a better observation. Okay, just like that. Now, so starting from sodium here, let's start with a few drops. Okay, so what did you see? Now you see the solution turns milky a little bit. Now actually this is quite obvious because calcium and hydroxide, they form calcium hydroxide, and you should have learned it in Form 3 that calcium hydroxide is slightly soluble. So that's why you see some white precipitate here, which is calcium hydroxide. So when we add more, now when it comes to more, that means basically a couple of pumps Now that should be more obvious that the calcium hydroxide is actually not very soluble in water, and that's why you will see the milkiness persist. Okay. Now let's move on to the second one, which is magnesium.
So again, we start from adding just a few drops.
Now you see, again, after adding a few drops, there should be some milkiness, but not as milky as the calcium hydroxide. So magnesium hydroxide is also not very soluble in water, so that's why you see the white precipitate. Now again, we will add extra sodium hydroxide. And now the solutions start to get more clear, so you can say that the magnesium hydroxide dissolves when excess amount of sodium hydroxide is added. Okay. Now moving on to the third one, which is aluminum. So let's add a few drops first. Now it should be very obvious that there are white precipitate. There are white precipitate that is formed as we add the sodium hydroxide. Now let's add more. Now here, after adding a little bit more, you see the aluminum hydroxide actually dissolve when we add excess amount of sodium hydroxide. So here you have to pay extra attention to this guy, because for aluminum ion, it actually forms aluminum hydroxide, Al open bracket OH close bracket 3, and this guy is insoluble in water. Aluminum hydroxide is insoluble in water. But as we add excess amount of sodium hydroxide, actually this insoluble aluminum hydroxide will further react to form a complex ion, and that complex ion is actually soluble in water. So for this particular sample, we have two observations. One is that when we add few drops of sodium hydroxide, white precipitate is formed. Secondly, when we add excess amount of sodium hydroxide, the white precipitate redissolves. Okay, so bear in mind these particular observations. Now moving on to the fourth one, which is zinc.
Now zinc, again, let's add a few drops. 1, 2, 3, 4, a little bit more, that should be fine. Again,
you should see some white precipitate. So what if we add excess amount of sodium hydroxide? So
let's just add a couple of pumps of sodium hydroxide and see if the solid redissolves. Now it should be fairly clear that
when we add excess amount of sodium hydroxide, the zinc hydroxide white precipitate redissolves. Okay, so this one is very similar to just now aluminum, right? Aluminum also forms a white precipitate when we add small amount of sodium hydroxide, but when we add a little bit more, then the white precipitate redissolves. Okay. Now moving on to the fifth one, which is iron 2 ion. Iron 2 ion. Bear in mind, iron we have two different ions, Fe2 plus and Fe3 plus. Now let's talk about Fe2 plus. Now first of all, Fe2 plus, I'm not sure if you see it clearly. Actually, Fe2 plus is having a pale green color. But very often we see it very pale that you may think that it is colorless. But actually, iron 2 sulfate, we say that it is pale green in appearances. Now, let's just add small amount of sodium hydroxide, just a few drops, and see what happens. Now, that should be very obvious. So, after adding the sodium hydroxide, we will see this little green in color. We call this one dirty green. So we say that for Fe2 ion, when we add a few drops of sodium hydroxide, it gives us a dirty green precipitate. Now, let's just add more sodium hydroxide. Now, it should be obvious that the green precipitate persists. It doesn't redissolve. Now, iron 3 ion, here obviously you see a pale yellow, or sometimes you can say brown in color. It depends on the concentration. Just now it is like yellow, okay? Now, watch carefully when we add a few drops of sodium hydroxide. So obviously, you can see it forms some kind of brown precipitate, right? Brown precipitate, okay? Now, let's just add more to see if it redissolves. So it does not redissolve. The precipitate is still here. Now, moving on to the 7th, which is lead 2 nitrate. Okay, just a few drops to see what happened. Very often obvious that we have a white precipitate. Okay, let's just add more to see what happened. Already you should be able to see it. Okay, just add a little bit more. Okay, now the white precipitate of lead 2 hydroxide redissolves. Okay, that is very obvious. So moving on to the 8th, which is copper 2 sulfate. We add just a few drops. Now, can you see? It quickly gives you blue precipitate. Blue precipitate.
Okay, so this is actually copper 2 hydroxide. Let's just add extra sodium hydroxide to see if it redissolves. So obviously,
it does not redissolve. Lastly, we have the silver ion. Let's just add a few drops. Wow, okay, it gives you a very intense brown color. Intense brown color, okay? So we say that for silver ion, it forms a brown precipitate. Brown precipitate. Now, this brown precipitate, you may think that it is silver hydroxide or silver 1 hydroxide, but in fact, it is silver oxide, silver 1 oxide, Ag2O, which is quite different from all these precipitate. Now, all these precipitate are hydroxides, but this guy, silver oxide. The reason is because silver hydroxide is very unstable. So actually, it first formed the silver hydroxide, but very quickly it decomposes into silver oxide. So this is actually silver oxide.
Now just try to add a little bit more of the sodium hydroxide. So
Do you think it redissolves? Obviously not. Okay. Now, so far we have talked about all 9 samples. You realize that there are 3 of them. There are 3 of them that actually forms a precipitate when we add a few drops, and then later on it redissolves. And those samples are the aluminum, and then zinc, as well as lead. Okay? So remember, for these 3 samples, white precipitate when we add a few drops of sodium hydroxide, and then the white precipitate redissolve when we add excess amount of sodium hydroxide. Okay? So now I'm going to clean up all the test tubes. I'll do exactly the same thing, but with ammonium solution. Okay? Oops. Okay, so I have already added to each test tube the corresponding solution and each 1 pump measure, except the silver, which is quite expensive, so I add a little bit less. So right now, I'm going to try using ammonia solution, basically doing the same thing. First, add a few drops, and then add excess. So let's start with calcium. So let's just add a few drops. So no observable change. So actually when you have no observable change upon adding small amounts, you don't actually have to do in excess. But just to show you for the sake of fair test. So you see for calcium ion, it remains clear no matter you add limited or excess amount of ammonia solution. Okay, so basically calcium ion does not form any precipitate upon adding ammonium solution. Now, before I proceed, let me again refresh your memory. Here we are adding ammonium solution, but we are not talking about the reaction between ammonia and the metal ion only. Some of them there is a reaction involved, but bear in mind when we add a few drops of ammonia solution, it is actually the hydroxide ion that reacts with the metal ion. Bear in mind, ammonia is a weak alkaline, meaning that it contains a fair amount of hydroxide ion. So when we add it into the metal ion, it is actually, first of all, the hydroxide ion that reacts with the metal ions. And after that, there may be some further reaction between ammonia and the metal hydroxide. Okay, so I will explain to you when we come across this situation. Now, where we at? We were talking about this, which is magnesium, right? So let's just add a few drops first. It is a little bit cloudy,
So we are expected to see some magnesium hydroxide as formed. And then we will add just a little bit more ammonia solution. Now you see
magnesium hydroxide persists. Okay, anyway, let's move on to the third one, which is aluminum. Now here is a little bit tricky, I will show you. Just add a few drops. And you can see we have some powdery precipitate, okay? And let's just add a little bit more. Now you see it becomes quite clear, right? It becomes pretty clear. So you may think that it has redissolved. But if you watch very closely, there are actually some white precipitate. Now here is the thing that we often find it quite complicated, quite difficult to demonstrate to you. It has been years having the same problem. For aluminum, according to the textbook, we say that aluminum, it does not redissolve when we add excess amount of ammonia. So actually the white precipitate is still there. This one should be milky. But a lot of the time when we actually perform this experiment, it appears to be pretty much clear. So it is quite difficult for us to judge that this one is being still a white precipitate. Actually there is, but it's very difficult to observe. So this is the test that perhaps the actual observation is sort of not really following what the textbook have mentioned. So you may ask, so what will we do in DSE exam? Of course, you follow the textbook. So that means you need to convince yourself in some way that aluminum hydroxide does not redissolve in excess ammonium solution. Okay, that's all I can say. But for others, that would be quite obvious. Okay, moving on to the next one, which is zinc. Zinc, so let's just add a few drops. Obviously, you see the white precipitate. Okay, let's just add a couple of more pumps of ammonia solution. This time, it quickly redissolves. Okay? So for zinc hydroxide, it redissolves in both sodium hydroxide excess and ammonia solution excess. Okay? Now, moving on to this one, which is Fe2+, just a few drops. already, you should be seeing the same thing, the dirty green precipitate. And when we add more, you see the green precipitate persists, so the dirty green precipitate does not redissolve. Moving on to the Fe3+. Actually, for this, I will be a little bit faster because they are actually the same as the sodium hydroxide. So brown precipitate, and when we add more, you see the brown precipitate persists, right? The brown precipitate is still there. Okay, moving on to this one, which is lead. Now for lead, if you remember, for excess sodium hydroxide, it can redissolve. But let's see what happens when we add ammonia. Just a few drops first. You should see again the white precipitate. And if you remember, if you don't remember, you can go back to the previous part of the video. For sodium hydroxide, when we add just 2 more pumps, then the entire white appearances disappeared. So let's see if that is the case for ammonia. Should be quite obvious, right? You see the white precipitate is still there, right? So it is quite obvious that for lead-2 hydroxide, it does not redissolve in excess ammonia solution. So, okay, what about copper? Now copper is quite beautiful. When we add a few drops, so it gives us again the pale blue precipitate, which is quite similar to what we had with sodium hydroxide. But watch carefully what happened when we add excess amount of ammonia solution. You should be able to see it. You see, when we add excess amount of ammonia, then it gives us this very intensive deep blue color. And if you watch it even more closely, you should be able to see that. Actually there is no precipitate there. So this one is a deep blue solution. In other words, the copper-2 hydroxide precipitate redissolve to form this deep blue color solution. Okay? Okay, now for the silver ion. Now watch very carefully what happened when we add the ammonia solution. So when we add just one drop, what can you see? Just one drop. You see this brown precipitate, right? Brown precipitate. Okay? But very quickly, as we add a little bit more, they are gone. Okay? They are gone. So here, for silver ion, when we add just one drop of very limited amount of ammonia solution, it gives us a brown precipitate, which is actually the one that we see when we add the sodium hydroxide. It actually forms the silver 1 oxide. But when we add excess amount of ammonia solution, the silver oxide actually reacts with ammonia to form a complex ion. Okay? Now, so that's why the silver oxide redissolves. Okay? Now, let's do a quick conclusion. So within these 9 samples, again, there are 3 samples that is able to form a precipitate first when we add a few drops of ammonia solution, and after that, that precipitate redissolves. What are the 3 samples? Do you remember? So they are, first of all, zinc. Okay? Zinc forms a white precipitate and then it redissolves. The second one is this very beautiful copper. So first of all, it forms a pale blue precipitate, and after that, when we add excess amount of ammonia solution, it redissolves and forms a deep blue solution. And lastly, it is the silver. Silver ion, it first forms brown silver 1 oxide, and after adding just a little bit more, it becomes a clear solution. So the silver 1 oxide redissolves to form a clear solution. colorless solution. Okay, so these are all the test tube experiment concerning about metal ions and with sodium hydroxide solution and ammonia solution. So you should be able to fill in this table from the report, and you actually need to memorize all the expected observations. So that's the idea. Bye bye.